Good evening, everyone, and welcome to SocialFlight Live. I'm Jeff Simon. We have such a great show for you this evening. Rian Johnson and Greg Hughes are here, both in order, President and Vice President of Vans Aircraft. Before we get started, just a few things from SocialFlight here. At SocialFlight, we've got, first of all, tens of thousands of aviation events and destinations happening. And so be sure to check out the app and the website, including tons of fly-ins, which you can see lots of Vans aircraft at. And we just gave away our, September 1st, our Fly to Win Challenge Lightspeed Zulu 3 headset. And of course, if you join, there are tons of other prizes that we are giving away on a regular basis there. Also, our SocialFlight Live show is now a podcast, so be sure to check that out on your favorite podcast source. Now, Rian Johnson and Greg Hughes lead the management team of the most successful experimental aircraft company in aviation history. Vans Aircraft has sold more plans and kits than any other manufacturer, and their customers have completed over 10,000 aircraft flying in over 45 countries. Vans designs are fast and efficient to fly, and more importantly, through CNC cut parts and unparalleled factory and builder support, Vans Aircraft has made home building something that nearly anyone can accomplish. In a world where the majority of aircraft kits never see the sky, Vans Aircraft stand alone with more than one build completion happening every single day. Their most recent design, the RV-15, is a bit of a departure from the past because the wing is on the top, poised to open the door to backcountry flying to future Vans customers. Please welcome to SocialFlight Live, Rian Johnson and Greg Hughes. How are you guys doing? Oh, hold on a second here. We've got, there you go. How are you guys doing?
Very good. Good to see you.
It's good to see you, Jeff. Thanks for having us.
Absolutely. Hey, so I want to get started before we get to the aircraft and things like that with a little bit from both of you, because your personal histories on coming to the company and the things that you've done there, I find not only fascinating, but everyone's kind of pet dream of what it would be like to work in the industry that is their hobby, that is their passion. And I guess tenure-wise, we'll start with you, Rian, as kind of the president. You've spent more time at the company. We'll kick off with you, but tell me a little bit about your background and the path that took you to Vans Aircraft.
Yeah, I've worked here. This is the only job I've worked at. So what do I have to compare it to? It was, I graduated on a Sunday and went to work for Vans on a Monday. I worked the first week for free because I just knew if I took all the easy, busy work out of the way, they'd have to give me a real project. I started, as a little kid, I was able to go to the local air show here. I'm from the local area, and I saw Van fly. So, I saw the RV-4 behind the ropes there, and you'd always walk up to it. I think I was 4 years old the first time I went to that air show. So, I got to see that early on. I never thought it would be a reality. Through school, I don't want to offend any of the big aviation companies, but I had job opportunities at other companies. And I was at a competition, and it was judged, and one of the judges happened to restore MiGs and knew of an opening at Vans. And I happened to give an aviation geared presentation that day, and I could see his eyes were lighting up. So we connected after that. I went to Vans house and talked to him. We both graduated from the same university. So
where's that?
Anyway, University of Portland. So we're both MEs, we're not aero engineering, we're not from that side, but we both have a passion for it. I think I'd read every aviation book in the local library system. This is before the age of the internet, and of course, coming to work for Vans where you can work, the only thing limiting you is your own inability for time and you can make changes to all parts of the airplane. I've worked on all parts of the airplane. The pace at which we work is only, again, limited by the time we have to spend on it. And so just the rate at which you can see change happen, you get to interact with the customer and see your end product, your design, or what other people have designed, and just the smile on their face. And that's something I don't think you get that at a large aviation manufacturer. And
No,
it's a special
probably
place
spend a
to
little
work.
more. Yeah, probably spend a little more time on process instead of kind of rolling up your sleeves.
Right.
It's interesting
Yeah.
that you talk about both you and Vance coming from a mechanical engineering perspective. I get a lot of questions from young people that are looking to get into the industry, and of course, both my sons, Jake and Ben, are both pursuing mechanical engineering degrees with that same goal. And it's interesting because people do ask the question, do I have to be an aerospace engineer to get into the industry, or is mechanical engineering good enough if my goal is to work on the mechanical side of airplanes?
We have a variety of engineers here at Vans, and yes, the arrows have their place. They probably know more in depth in some aspects, but after enough years in the industry, you'll gain that knowledge as well. But if you have the broad spectrum, I've worked on everything from printed circuit board design. We brought that with plug and play wiring systems to the RV-12. That's the first place that showed up. And then also we have the system that closely mirrors that on the RV-14, where you build the harness into the airplane. So you work on everything from electrical to design of the airplane. And of course, we're a small company, so our recent hydro press, I designed the footing for that, and how do you support 90,000 pounds of a hydro press that's smashing parts? It's a small company, and the challenges are unlimited. But
Vans, when you need to expand the factory, you don't go hire somebody to do it.
Yeah.
The president, chief engineer, and chief bottle washer
Chief bottle washer,
works from
definitely.
11 p.m. to 4 a.m. every night designing footings in the new building, and then
Yeah, it's
then
fun
find some
though.
contractors to make it happen. So
Right.
that's kind of the way we work. We work hard and fun is what we do here. So
Now, Greg, okay, your story is amazing, and for anyone out there who wants to go take a search, you've got a letter online that was your letter of applying to join the company, which it just puts such a smile on my face.
Well, I'm glad. I don't remember what it says, to be honest with you. It's all lies. Totally all lies. No, until you reminded me of that, I had actually forgotten about that. Somebody mentioned it to me a couple months ago. That I was Googled your name and I found this. It's like, it's kind of cool. I've worked at Vans now for just a little over 4 years, so I'm still a baby here. I'm new, right? Still figuring things out. I didn't fly until I always wanted to fly since I was a kid, but I didn't get into aviation and actually got my pilot certificate, in my early 40s. So that would have been, in 2000. I think I got the ticket in 2009. Started training in 2008. Bought a Cherokee, and then kind of found RVs through Team Flight, the program that was here, that started here. And now there's a whole bunch of RV-12s being built by different STEM programs around the world. But this is the first one, this program here in the Portland area. In fact, the very first airplane was built here in the Vans factory with teenagers. And since then, it's moved over to the Hillsborough Airport across the city. But, I had spent a lot of time working with kids in various capacities, in my prior life, working with at-risk kids, and a lot of backpacking in the mountains leadership programs and all kinds of stuff. And so I knew kids pretty well, and I was just starting to get to know airplanes. And I think it was here's the engineer thing, right? So Van's brother, Jerry, so Van and Jerry and Stan, three of the brothers, are all involved in mentoring and Team Flight and teaching the kids, and still do that every weekend, right? And they're there and working every Saturday with these kids. But Jerry I got to know them through EAA, our local EAA chapter, which is at Twin Oaks Air Park, the same airport that I learned to fly at. Jerry came to me and said, we've got this program. I don't know if you've heard it or not, but we're building this airplane. Building these airplanes with these kids. And he says, we got a whole bunch of engineers there and a bunch of people that think like engineers. And so we really understand how to build the airplanes. We have no problem with that. And he paused and he said, but these kids are pretty hard to figure out. And so they basically asked if I wouldn't mind coming by and maybe seeing if I might be able to help out a little bit with that. So that's what I did. And then from there, kind of caught the bug. And a friend of mine there is also mentoring. Yeah. So am I usually. But a friend of mine, friend of mine there, Jim, was building an RV-8A and project and had decided that, he was not going to finish it. And I picked that up from him. So I'm one of those used airplane project buyers. Got into that. And, sort of one of those organic paths, right? It just sort of does what it does. I really caught the bug, to use the present vernacular. And I've been working in cybersecurity and prior to that in law enforcement and stuff for a few decades. But I decided that I was done with the great big Fortune 500 company, the big company process thing, and that I wanted to change. And opportunity happened to come up here. And I was talking with my stepdad. It was right before he died, and he's the kind of guy that's kind of like, you got to save. You never, it's important. Retirement, you got to do all that kind of stuff. But he said to me, he said, "Well, are you happy doing what you're doing in the prior career?" And I said, "No, not really." And he said, "Well, you know what you want. You know what you love and what you want, right? Because you know aviation." I said, "Yeah." And he said, "Well, then what's stopping you?" And I said, "You're the last person in the world that I thought would tell me it's okay for me to make that kind of financially irresponsible decision." But I did, and I haven't really looked back. It's been a lot of fun. It's a great company with a lot of really amazing people and a really cool product, right? And the airplanes are amazing, but more amazing than the airplanes, at least a little bit more amazing than the airplanes, are the people that work here and the people that buy and the kits and build the airplanes and fly them. It's a great community, a bunch of really amazing people. I know I've learned an awful lot since I've been here.
Yeah, there's no end to learn.
Yeah,
but customers as well.
But and I'm not an engineer, right? I'm a guy that's worked in several industries over a few decades and has put together some experience. But I'm learning to build an airplane just like anybody else that picks up their first kit. And I come here and I've never worked in a factory before. I've certainly run teams of people and whatnot, but coming here to do this was a pretty big learning curve, and I'm still learning. But the cool thing is that I can come here and I can learn some of this stuff, and then I pick up new skills and I get to continue to learn and grow and have fun and do new things. And Ryan's point that that you made a few minutes ago about this is a kind of company the size that we're at, where you still have an opportunity to idealize something, to have a concept, and to take it to full fruition products in the hands of customers and stuff. And I see that our engineers here, and we have an amazing engineering team also, but it's a unique opportunity to be able to do something that is so broad reaching and own it from sort of soup to nuts, right? It's the whole thing, beginning to end, that we're able to all of us are able to do that. That's really a big part of what makes it so much fun to work here.
It seems to me that when we look at all these different companies that make different experimental aircraft, and I root for, as you do, for all of them, right? We love
Sure.
all this. Vans is unique in that it has such a well-defined kind of like identity and group of priorities almost as a company. You tend not to, you evolve and you come out with really innovative things like the 15 we're going to talk about. However, everything seems to be very, very true to your roots and what those priorities are. Tell me a little bit about that concept of really kind of being, in a way, you can almost think of it as being rigid, but in a very positive way, like making sure that whatever you do sticks to those.
I think of it as a strong foundation.
That Van said, right.
Right.
Everything's built on honesty. So beyond being honest with the customer, you have to be honest with yourself when you're designing something, because you can't design something that is unattainable or compromises too far in one direction so that the overall design becomes something nobody would want to fly, or not many people would want to fly. Mm-hmm. So, honesty as a designer, you can't just design for your own body size. You have to design for the market, right? So, just willing to go back and get it right and keep iterating, not get stuck in documenting, but rather test, iterate, get things where they need to be, what the customer would want to feel, what you want to feel in the airplane when you fly it, and how it performs. I think is driven by the fact that Van had to fly out of a very short strip, but he wanted to go fast. So why do I have to compromise? And it's driven also by a respect to the aesthetic. So, he was the first person to really have good quality bubble canopies and fiberglass. I would say if you compare him to other kits in the early 70s, late 60s, it was a leap forward. And anyway, over time, put all that together, and we're where we're at now.
And it applies not just to new ideas, but also to refinement of the existing airplanes. It
Right.
applies, advancing the state of the art there. It applies to safety, right? And
Safety is a big driver.
honesty and safety is a really important thing in this industry, right? There's times, if we discover something that we need to change and we need to let people know about, then we change it and we let people know about it. It's a
Stories, stories make these kind of fun, these interviews. And I remember the year the RV-10 rolled out, just to tell you how honest Van is, we're about to leave for Oshkosh. Everything, there's not much time when you leave for Oshkosh because you have to do a zillion things. And
you've probably just painted the airplane.
Yeah, the paint's still drying.
It's still drying as you,
And right in the next room over the front counter of the company, I remember we had piled all the flyers for the RV-10. And Van walks by and he picks one up. And the media guy at the time had published 200 miles an hour for the cruise speed at the time. And Van said, no, it's 199 at the most, but I think it's 198.5. And you can just see the look on everybody's face. And he forced, those to be reprinted. And we would not go to Oshkosh with 200 because it was a nice number, only 1 mile an hour away. So, there's where it started. And I was an intern here, and I came back after the first internship. Just on his honesty was one of the main drivers, and it just reflected, where I'd come from. My own business background, and this is going to work. It's going to go somewhere.
And you started as an intern in
98.
98. Started as an intern at the company, and now
so we were finishing up the RV-8 at the time.
Now he's the president
98.
and the chief.
You were telling me when you first came in, you started work on your first one was the first RV-7A.
I did work on an RV-7A. So after I started. Well, I was, I was pretty young, and I wanted an airplane any way possible, and I didn't have a shop to build it in, and I realized I could build everything used and poorly, or I could get a partner and then eventually buy that partner out and, have better quality items in the airplane. So I did get a partner, and he wanted a side-by-side, so we started a 6. And I realized after building the horizontal tail, where I had to build a jig for it, and the holes were only in the skin, and you had to drill it together and draw a set. I mean, it's just a nightmare. That my time would be better spent making the parts matched whole, and I'd still be far ahead, time-wise. And at the same time, Van came in with drawings for a common 7/8 wing, where we'd up the gross weight, aerobatic gross weight on the RV-8 wing, and then make a common wing with, RV-6, and I said, yes, I'll go for that. And Ken Kruger at the time was working on the RV-9 pre-punched, and so I adapted part of that, and I started working from the front of the airplane. He's working from the back forwards, and we met in the middle with different center section and those wings, and that became the first RV-7. So my RV-7 has a RV-8 rudder, a RV-6 horizontal, RV-4 wingtips. And it all came home to my lunchbox, yes.
It's an RV-7A.
Yeah, it's an RV-7A.
Yeah.
That's awesome. And it also seems like the focus on so many of your designs, as you talked about just now with matched hull, is really on completion. That's a big part of everything that you guys do. Can you talk a little bit about that? Because that certainly plays in as we get to the RV-15.
Yeah, I remember on the 80s, I was born in 76, so the 80s I wasn't that old, but you'd read Kit Planes magazine, and of course Lancer was just across the mountain range here at Bend, and you had Burt Rutan and all the composite designs, right? And so that was the sexy airplane out there. But in the end, it's a lot easier to build a metal design. It's also easier to repair, and the cost and just the ease of repairing a design. And so I think that's why, you know, what we have as a kit wins out in the end, in the long run, in that effort. And matched hole, yeah, we got our first punch press in '96, and so that was just happening when I was here. We really didn't figure out the math for it until about 2005 to really dial it in. But matched hole, it's more than just the design. It's the fact that our employees, down to the level of the press brake operator, care. And you know, we may put a plus or minus 10 thousandths tolerance on the drawing, but the punch press operators are trying to get plus or minus 2.
Wow.
You know, so every employee is out there just trying to make the parts as accurate as they can. I can't speak enough for our employees here at Vans. That's also what makes matched hole technology work. But yeah, once you had the holes in the, I remember the first 7 wing I was talking about, and I was trying to go quick. We did that whole wing design in 5 months, from the beginning till the plans pages were done. And we built in 1 day a wing for test. Of course, we didn't care about the long-term durability, a structural test, and it had 0.1 degrees of twist, and we built it on a tabletop and self-aligned. So we were just going at it, and
Game changer.
Game changer, yeah.
Was it a long day?
It was a long day, but it was Phil Dyke. He was amazing. He was an A&P mechanic that could work at warp speed.
He is amazing.
What do you mean when you say that it took you a while to get the math right for matched hole drilling?
Oh, that's the secret sauce. We can't tell you about that. But interestingly enough, the math wouldn't work out right. We worked out our own algorithms, and my mother gave me this differential geometry book from the 1800s. You know, it looked good on the shelf, and I picked up the book afterwards, and it had the solution in there. But there is some math to it, but there's also a lot of testing involved. So we have a lot of good testing capability here at Vans, and we spend time on testing, and we want to understand why. And so a lot of tables and charts and testing back and forth so we can dial in, okay, does the skin have vinyl on it? Does it not have vinyl on it? The vinyl is only a 64th of an inch thick, but we account for that. So when we're dialing in matched hole, we're trying to take into account every variable and you know, try to get those parts as close to where they need to be as possible.
We start with a piece of aluminum sheet typically, right, and of varying thicknesses, but that has a tolerance. We put that blue vinyl on either side of it to prevent it from getting marred and scratched. We do that in-house here, right? And then we take those big flat sheets and we load them onto a great big CNC punch press, which punches holes of all different shapes and sizes and basically cuts out and punches holes in all the parts. And then we take those flat sheet parts, we take them over to the CNC bending brake, and the guys on the bending brakes take them and they load them in and they hold it there, and then they put their foot on a pedal and a program runs and it bends it. But that bending, I mean, if it matters whether the blue vinyl is on there or not, whether or not it's within tolerance, whether or not the metal is within tolerance thickness, and they check all of those things. So to go from an RV-3 where it's like, here's some aluminum and draw some, you know, get your markers out and draw on it and cut it out and then get out a rivet fan and figure out where the rivets go and good luck. And six pages of instructions to where we're at now, which is, you know, I mean, I don't want this to sound negative, but it's kind of like paint by number for airplanes, right? It's literally on the page,
follow
step
every
one, step 2, step 3, and here's the pictures right next to step 1, step 2, and step 3. Refer to figure 1. You know, and you know, we've gone these really 3 big evolutions of kit, right? There's the you figure it out, you cut out the metal, you know, maybe the parts are cut out, but you need to figure out where the holes go. You do all of that work. Then there's the match drilling, you know, you got holes in one of them.
In the skin, but not the understructure.
But not the understructure, so you drill through. And then evolving from that into matched hole, right? Where it's matched hole and the holes all line up and you can click it together and it's a self-jigging thing, but you need to final size those holes. You drill them up to the final size. And now, you know, with the 14 and the 12 and recently the 10 updated, it's pre-punched, matched hole, and they're final size holes. You don't even have to upsize them or not. So check for burrs, and where you find burrs, deburr the things, all the parts, edges and holes, and then start assembling the airplane. You mentioned earlier that, you know, completion, you know, completions are up. So the percentage of kits that are sold and are completed, number one, there's a higher percentage that are completed, much higher percentage, and they're also completed much more quickly, right? Mm-hmm. So, you know, the RV-14 is a big airplane. it's a pretty sizable airplane, but, and it's, we call it the Bubba 7 or, what have you. It's a big 2-seat side-by-side airplane. It's got more rivets and whatnot than an RV-7 does, but it builds quicker. And it actually builds quite a bit quicker. We have a lot of people, it's their very first airplane. They built it in less than 18 months, and in some cases less than a year.
Right.
Wow.
And so the level of refinement that, that Ryan and the engineering team have put into the kits, and all the engineers that have worked here over the years is really pretty amazing.
Right.
It's opened the door to people who otherwise may not have really felt comfortable with the opportunity.
So let's talk about that for a second. Let's talk about the RV-15 and what it takes to go from this kind of, I guess what could be viewed outside the company as incremental designs that all look, there's a certain look, there's a certain thing that looks like one kind of begot the other one. The RV-15 is a bit different, at least when it comes to that wing on top. So what's the key there, and what was involved in bringing something like that to life?
Well, it's not only different in appearance. There are essentially no parts on the RV-15 that appear in any of our other airplanes.
Right. Yeah. Every part is pretty much different. We didn't want to constrain ourselves. I know in the 14 we thought we would reuse RV-10 parts out of the tail. There was ideas we had. In the end,
yeah,
it was all new parts anyway. So why constrain yourself from the beginning in the thought process? Yeah. So we wanted clean sheet design,
especially as the ideas started to come out. Right.
Right.
Some of the detailed ideas, it became real apparent.
But it really started from a marketing standpoint. I mean, if you really want to go back, it would begin in somewhere around 2001, 2003 when the conversations first started. Mm-hmm. And then Van and I at Oshkosh would sit and debate back and forth. It really, what size of airplane that we were going after. That was the hard thing to nail down, because we could have went multiple directions. We could have went to a large 4-place, which would have competed against the RV-10, maybe somewhat, but hey, if that's what the market really wants. But yet we want to bring airplanes to the widest group of people possible. We don't want something that's so far off the end of the cost spectrum that we're not going to hit the person who really wants an airplane, and we're just not letting them have it just due to price. So I didn't want to price them out on the size of the engine and require a large engine. So we wanted to target 180 to 220 horsepower range. And also, I looked at a lot of the airplanes that came up from the lower end of the spectrum, and well, they started out with a 100 horsepower engine, but now they're trying to put a 320 on it. Why? Obviously the market's pushing them that way. So I don't want to design an airplane for too small of an engine. We know from our experience here, like the RV-10, we offered 2 engine choices, and I think one person took the smaller engine in the history of vans.
I looked it up, and I think that's correct.
Yeah.
And I think it's one of our demonstrator models.
Yeah. Right.
I don't think there's a customer airplane flying with a smaller engine.
All that time spent, and why make the smallest engine choice so small that nobody ever goes for it? But we do know that 180 horsepower will make a lighter weight airplane in the case of the 15, and anybody who's flown a lightweight airplane knows how much fun it is. And I get to fly airplanes back to back here at Van, so I can jump in my 180 horsepower RV-7, and then I can jump in the angle valve RV-7 here, and I can tell you I'd much rather do aerobatics in my airplane, although I can climb better in our RV-7 slightly. Yep. But besides impressing people with the climb out at the local EAA breakfast, I'd rather fly my airplane. So we wanted to allow that lightweight option on the 15. People will want to do it, and it'll have some merit.
When we think about what are we going to do next and why are we going to do it? I mean, Ryan's alluded to the fact that there's a pretty complex set of decision calculus, I guess, right? So there's the I'm the marketing guy, and I hate to think about things in terms of market, when this is really a sort of a hobby of passion, but we're a business, and so exactly. we need to be able to produce things that really put the grin on people's faces and really excite people, including us. And if we're not excited by it, we're builders too, right? So there's a good chance that that's usually a good clue. But the concept of total performance, which you've kind of alluded to, right? You land slow,
but still go at reasonable speed.
but go at reasonable speed, and stretch that envelope as much as you can without sacrificing, flying qualities and all the important things that make an RV an RV. Conversations around high wing airplanes started 20 years ago, give or take, probably, when about what would make sense and when, and it started to make more and more sense. We did a huge survey here a few years ago, about 2.5, 3 years ago, with about, we didn't tell anybody we were doing it, but we did it, and with about 4,500 responses, where we were able to take a look at and really understand with volumes and volumes of comments and a lot of patterns of information that we were able to better understand. I know I went to fly-ins and visited people all around the country and asked questions and had 30 and 90-minute conversations around, what would you want? What would you like the next RV to be? And you've done the same thing. And those conversations are really valuable. And I really feel pretty good that what we've put together and built in the RV-15 is really pretty well hits the mark. And it's not that that's the only idea we got. We got other ideas too, right? And, so there's more than just one airplane worth of information and ideas that we have. But this is the one for now.
Right.
I'm excited about it. I think it's going to be.
What were the top design goals for the airplane? If you were to kind of like nail it down to a few things, what would you say the RV-15's top design goals were?
We wanted to be able to safely allow people to go off field. So that was a design goal that drove quite a few other decisions down below that, because we realized that, okay, people want to do this. How many people really go off field? But if you're going to go off field in a reasonable off field, obviously there's rough terrain that we don't intend the airplane to go over. But if you want a reasonable off field capability, how can you do that with an average pilot and allow more people to safely go out there into the field and enjoy the camping, the outdoors experience, everything else that STOL represents. So that was an overall design goal. Real baggage capacity, we wanted that top speed. So RVs are known for their speed ratio, it's called, the ratio of the stall speed to the top speed. And how do you not compromise that? And there's quite a few things that boiled out there, but we still wanted a reasonable amount of baggage, and that includes baggage volume. So back to another story, where Van and I are sitting there, and we have a corner office that overlooks the parking lot. And anyway, Van and I are talking about baggage capacity, and I said, well, it has to hold a bike. We see these magazines at the bike hanging on the strut, and to be honest, I don't know what the vortices coming out the bike are going to be anyway. It kind of, I guess it works. I wouldn't personally want to do it.
It's a little draggy.
If I can put the bike inside, why not? And Van says, well, you drive this little BMW, coupe. You certainly don't take a bike with you in there. And I actually have put 2 bikes in my BMW coupe with the seats down. So it is possible. And he kind of threw up his hands at that point.
And I'm sure you drove back the next day.
Next day with the bikes.
2 bikes.
No, I didn't. We accepted each other's opinion at that point. But I think we came to the conclusion that, if we're really going camping, there's things that take volume, right? It's more than just weight. You can have items that aren't that heavy. I have a lightweight bike that I bought, and it's 14 pounds. So it's not that heavy, but it does take up a volume of space. And we didn't want to compromise that cruise speed by putting all these things outside the airplane. We still wanted the lift struts because we want the airplane to be lightweight. So you can make a lighter weight airplane with the lift struts. And even from our early conversations back in the early 2000s, you need a strut to push on. And float planes usually prefer a strut as well. So there's many reasons to have that strut out there. So that decision was made rather early on. And then the headroom. It's hard when you have a spar compromising your headroom. RVs are known for allowing tall pilots to fly in them. On RV-10, RV-8. It depends on your torso leg ratio, but usually 6'8" person can fit in those airplanes.
It's not 8 foot.
not Super 8. Yeah.
It's interesting that you bring that up because that's a big question that people have, right? Is a lot of people think modern design would equate to not having struts, and they were looking for vans like, oh, this is going to be the first one that doesn't have a strut, kind of like what Cessna did with the Cardinal. But you brought up the reasons. I think that's kind of important for people to understand why that happens. Because is it true that, I mean, do you pay a big penalty in speed because you have the struts?
Yes, you will pay a penalty in speed, but you gain it back in the lightweight end of the spectrum. So again, a lightweight airplane, the lighter weight you can make it, the more you use the load you have, the more performance you get out of the horsepower. And we saw this airplane as speed is nice, but it's not going to be king. It's not going to drive the airplane, but we still want to be able to fly to our destination because it's probably far away. You know, we live right next to the Idaho wilderness, not too far away. But we realize there's people that might want to fly from Texas up to Idaho or, you know, further distances.
Well, and you know, just to put a finer point on it, we live relatively close to Idaho, but it takes a lot longer to get there in a Super Cub than it does in an RV-7, right?
Right.
So, you know, and a high wing airplane, you know, an RV-15, maybe not quite as fast as an RV-7, but you know, relative to some of the other airplanes that might play in the same, some of the airplanes that would play in the same, you know, sandbox, if you will, you know, our what we've seen so far, we think we'll be able to do it, and certainly our hope is that we'll be able to get, you know, relative speed performance out of it that'll be appealing to people.
We'll have a custom designed extrusion in the end and fair both ends, and so it'll be as good as it can be.
Yeah, the current airplane, you know, you've seen it, right? And a lot of people have seen it, and there's certainly pictures online, but there's an awful lot of chunky, draggy stuff hanging out there.
Yeah, they were from Struts R Us, and bolts still hanging out there, and no intersection fairings, and
we're already seeing.
So we're looking at 140 knots cruise speed with the small, you know, 6x6 tires. That's the target. And I know from I flew formation with the 15 to Oshkosh. And back to your comment about it looks like an RV. Yeah, the wag your wings on the flight into Oshkosh, they said, yeah, RV and the Cessna, rock your wings. And we were trying to keep the 15 quiet, so it's like, I won't respond back to that one, but it was sure tempting. Anyway, so yeah, kudos to Cessna. They made a nice looking airplane. But you know, we hope by the end of this you can tell the RV-15 is an RV-15.
I think no question about that. And like I said, I mean, I think it makes a lot of sense what you're saying. I think the average person was just looking at, well, this is a company with expertise in low wing that kind of was built that way. What are we going to see kind of carried over? And speaking of which, that's kind of interesting because when you think about the tail and there's quite a few departures. Tell me about the Stabilator approach.
The Stabilator approach, it's built on many things. So I'm hangared with another competitor's airplane. It's from the certified world. I won't talk about them, but I know the way that my hangar mate flies the airplane, and you know, he likes to fly into sandbars. He gets over on the approach to the sandbar. He runs out of elevator control, and he's ended up gunning the engine to keep airflow over the tail. And as much as possible, I didn't want to run out of control on the tail. And one of the airplanes that we've respected over time, we looked at quite a few airplanes and tried to draw the best out of a number of airplanes. We had a matrix of 60 airplanes, and we dialed that down to about maybe 8 at the end that we really tried to take features out of. But one is the Helio Courier. That airplane uses the same airfoil as the RV-7, for example. You know, it was designed at MIT. They knew what they were doing. It's known for its real still performance. So I said, well, what did they get right in this airplane? And there's a local guy who happens to have 3 of them. He crashes one every once in a while, which is why he has 3, I think. And
he used to have 3.
Used to have 3. Anyway,
doesn't have them anymore.
He let us come in the back door, and you know, I got to look at that airplane when it was apart, and see what made that airplane work. And so there was respected designs out there. The Helio does use a Stabilator. And I know it had, you know, you have structural concerns. See, it had to solve that problem when you have a Stabilator, especially in an environment where you're beating the tail up and down. It gets a lot of abuse. and we solved that. So also with the suspension system on the airplane, which we can get into later, but
there's some really
right.
That's the other thing is that our engineering team is a bunch of really talented, been there, done that folks from
Right.
various parts of the industry, and there's some pretty nifty stuff designed into this airplane. And
Right.
I mean, the suspension system is just one example of that. But
that'll protect the Stabilator, because I know there is concerns about the structural integrity of it. Where a Stabilator gets most of its abuse is on landing and what the tail's going over. Not from the air flight loads. So a Stabilator is just a lot more effectiveness. We used it on the RV-12, so we knew most people when they fly an RV-12 for the first time, they over-rotate the airplane, and then they're fine the second time. But they're just not used to, if they fly a conventional tail, the amount of power that you can get out of a fixed amount of area. So we wanted as much tail authority, and of course we had planned to maximize the flap area. If you've seen the flaps, they're sizable.
Oh, yeah.
And you have to be able to offset that pitching moment. And also on a high wing, depending on if those flaps start deflecting the airflow down and away from the tail surface, you still have to have tail authority to be able to pitch the airplane.
Mm-hmm.
But back to the safety aspect, which drove it from the beginning, if you're on approach, you want to be on approach and just set up for approach and not have to touch anything, and then execute a great landing and make the airplane. One thing the RVs are known for is making the pilot look good. So, if you're constantly, adjusting things at the last minute there, or even gunning the engine, it's like a variable thrown in there. And, a stable approach for the average pilot is what we were after there. So if you have enough authority, we believe you could do that.
That makes a lot of sense. Now you mentioned the landing gear and the shock absorption system, and that has gotten a lot of attention, including a video that you released that shows how it works, the patent that you filed on it. Tell me a little bit about that, because landing gear and suspension on anything that's going backcountry seems to be everything everyone talks about.
Right, and the biggest difference here, and we're using TKS Shock Monster shocks. The difference here is that it's all internal, right? So, there's a shock on the tail wheel. So Ryan's talking about, taking some of that abuse that goes into the airframe, into the tail, into the main structure of the airplane, and taking that and turning it effectively into heat inside the shock. So in the belly of the airplane, underneath about where your knees would be, it's a flat floor, continuous flat floor on the top and flat bottom. In an area that's about this big, there's 4 shocks, 2 for each gear, independently suspended. So you get, that when you're going backcountry and you have spring gear, right? It looks like spring gear, but it's not spring gear. When you have spring gear, you take a lot of energy out, but then it has to go somewhere and it goes back, right? And then the airplane tends to do this. Whereas in this case, it's fully dampened on the way out and dampened on the way out and on the way back in. If you were to see it, we saw it taxiing, over at a local airport out on the bumps and stuff and doing some takeoffs and landings, and been doing refinements even since Oshkosh, right? It takes a lot out of it. But the cool part is that, it's in this little area down there. You don't even know it's there unless somebody tells you about it, which is why we've been telling people about it.
No drag.
And there's no drag, right? So, to Ryan's earlier point, we want to build an airplane that'll perform on the low and slow end of the spectrum really, really well. We also want to maximize how much we can get out of on the top end of the performance spectrum. And there's some really unique design features about the way that it's done and the way that it works. To not just do things like act like a shock and take out some of the absorption, but to maximize the efficiency of doing that, and to do it in a way on the tail wheel that can help to eliminate things like shimmy and wear and tear on the tail wheel mechanism that you get on a typical tail wheel mechanism. And Brian Hickman's the engineer who designed that.
Excellent job.
Super sharp guy, and as are everybody that works there, but really neat stuff. And so, there's been some opportunities to innovate on some things working on the airplane, and that makes it that much more fun and a little more exciting. We have plenty more ideas that we'll try to plug into it as we go.
What are some of the things that people, even if they came and saw it at AirVenture, may not necessarily have noticed that you're especially proud of in kind of unique features of the aircraft?
The visibility, because they wouldn't have been able to sit in the airplane at Oshkosh. We had it set up for flight test. We purloined a Cessna 150 seat. If you wonder where it came from at the last minute, and threw that in the airplane. It wasn't last minute, that was built early on, but it's just we didn't have time. But you wouldn't have been able to, the visibility in the airplane. So we're used to low wings with really great visibility. I mean, the RV-12, the over the nose and over the wing, the RV-10 has the same feature because you're sitting so far
you can almost
forward.
look straight down.
You can almost look straight down in RV-12. Yeah. So we didn't want to lose, that with the high wing as well. We didn't want your eye to be up in the airplane next to the wing, where you're looking at the wing instead of out the airplane. So I designed it so your eye would be just below the door sill. And if you wonder why, our doors are opening forward, and once the airplane goes on floats, that's actually preferred, so you can help steer the airplane with the door. There's other reasons why people like in a float airplane the door is going forward, but I didn't even want to waste the space beneath the wing to have a door that pivoted upwards. So keeping that visibility as good as possible looking out the side of the airplane. But then the over the nose visibility, it started out with the 14 configuration, pilot and engine relationship, and then we just tweaked it from there. But we have, I think we dropped it 1.3 inches up near the nose of the airplane.
The visibility of sitting in the seat and looking out the front is just incredible. Right. If you sat in a 172, for example, and you got that 172 mic and that panel's coming up to right about here, it's about your nose level.
Right.
If you're my height, at least. I'm not the tallest person in the world, but this is fundamentally different. The panel's down below your chin, and when you're looking out, you don't even really see the cowl because the cowl is moving away from you here, and the visibility out the front is pretty incredible.
So Axel Alvarez, we haven't mentioned him yet, but he's our test pilot, known in the RV community. We're so happy to have him join our team. And on the first landings, he was three-pointing it without knowing it. A, because you have the suspension system, and B, because he was trying to get the nose up higher to get a better visual picture, and he thought he was wheel landing. So, and then the view out the side door. We have another door underway that's composite frame that's more conventional, but we still want to give that lower visibility plexiglass in the lower portion of that door. Maybe we'll have a fold-up window in the upper half of that door, but the current they're plexi all the way down the side, so the visibility there that you can see straight down.
I was going to ask you if that's a real thing, right? I mean, a lot of people have seen that and said, is that kind of like going to the auto show and seeing, what it could be, or is that for real?
It won't be exactly the way that it is right now.
It's never straight down. I mean, if you did a flower drop contest, I'm sure you'd realize that straight down isn't straight down. But yeah, it's pretty amazing, the view looking down out the side of the airplane.
So people are going to be able to get that full plexiglass door.
Yes, we'll call that the observer door, and I don't even think we need to bulge out. The airplane's the same width as a 182, wider than the early 180s, Cessna 180s. So yes, I did fly a 180 as part of this project a bit, and yes, I do bring my measuring tape with me everywhere. And inside the upholstery on the airplane, it was 39 inches. Well, learned that from Van. Yeah. And anyway, it was 39 inches inside the upholstery. Well, we're 46 across, so it's same as a 182, same as an RV-10, same as an RV-14. And with only the width of the plexi, you're getting that full advantage. So we might have a door that is bulged out on the side, but you already have the great visibility down. So I'm not sure that's even necessary, and why go any slower, why disturb the airflow. So those will be the observer doors, yes. But one thing that they wouldn't see at Oshkosh that we really tried to design, one of the design goals, I had got in a lot of other airplanes, and they're hard to get in and out of, especially if they have a control stick, to get your foot around them. And I would have Van get in and out of different airplanes, and it gets interesting. He's 83 years old. He's very spry. He'll get down, pop down on the ground, work on underneath his glider and pop back up. And, getting out of a glider, you're in a flat position anyway. But he's pretty spry, but still, getting your leg around the control stick or even getting up in an airplane, those are things that we wanted to make as easy as possible. So if you slide the seat back to the B pillar, that's the pillar at the back of the door opening, and then the control stick is a D shape. So you can push that forward and swing your feet in behind it, and you're right in the airplane as easy as possible, and then slide the seat forward. So we extended the tracks further back just to get inside the airplane, and the door size is not only to allow baggage. Now, when you put baggage in the airplane, what that seat that we had at Oshkosh doesn't show is I plan on putting a slit in the front of the seat, and that'll be able to slide up around the control stick so that you can slide the seat up forward and up to the instrument panel, so the back is up against the instrument panel, and only the width of the stick is between you and the instrument panel. And then you won't have to remove the seat to put things into the airplane, like bicycles. We can put a bicycle in the airplane without removing the seat. But also, you can lock the control stick. It makes a great control lock just built into the seat at the same time. So those are little details, but mainly the visibility, because that's key. With this suspension system, we have 7 inches of travel at the gear right now, and we're looking at playing around with ratios and altering that as well. But at 7 inches of travel, even on the 6x6 tires, we're operating off that. It's not on the runway; it's on the grass portion over there. It's not that improved, and you can operate on some pretty rough stuff if you have 7 inches of travel and 6x6 tires. So you should only have to go to 26-inch tires. We will try larger tires, but then you retain that great over-the-nose visibility.
Right.
So when you're landing or when you're taxiing the airplane, and we feel that will make the airplane a lot safer. And we had a whole engineering meeting where we watched the Valdez STOL competitions, and you watch people coming in like this. They can't see, try spot landing when you're coming in at that altitude versus the airplanes that were more reasonable, came in at a lower deck angle. You have a lot more control. And insurance rates are real. We all know that. And RVs, we have equivalent safety record at GA. So long term, I'm looking at how can I design this airplane so that insurance companies will insure our airplanes like they do currently at the same rate that they do GA airplanes. You can go out, my airplane I play the same rate that the guy hangared with me in the certified airplane is paying. So I want to retain that, and I have to find a way to make the airplane safe to fly.
Makes sense. So you're looking at people being able to go off field before even going to bush wheels and big things, that they should be able to do some stuff.
It would be 26-inch tires. Really it's more about what the tire is going over, because of course you don't want an object above the axle line of the tire. So if you're on a sandbar that has reasonable rocks, you want the 26-inch tires, right, just to be able to go over objects. But once you get to 31s or especially above, a couple of stories there. There's a local airplane manufacturer, not really in business anymore, and they had, I'm not sure what they were. They'd be the largest tires I'd ever seen.
They were huge.
I mean, it had to
they're
be.
flying 34s on one that still flies.
Yeah, okay, but it was much larger than that. And I watched him ground loop the airplane, and the tires would bulge out. They got in this oscillation. I know Van was down at a glider competition, and they had a STOL airplane there towing gliders, and guy got on the brakes. And if you have that large of a tire and that much moment from the brake action, over on the nose you go. Right. So there's a balance there. So you need a tire large enough to go over the objects that you're going over on the ground, and then let the suspension system do the work. And you're going to go faster if you have a smaller tire as well.
Right. No, that makes a lot of sense. Tell me also about when it comes to the building of the aircraft. Now, you've obviously gone with pulled rivets.
But I have news.
Kind of.
New news. This is new news, not released from Van's aircraft. So.
This is post Oshkosh news.
Post Oshkosh news.
Breaking news on SocialFlight Live. What it's going to be.
So I wanted to allow, as engineers, we wanted solid rivets. Especially when you think of a seaplane, the long-term durability. floats introduce really high loads into an airplane. And we have ways, we won't reveal them yet, how we think we can even help that. But pulled rivets, we wanted solid rivets. But we have thin skins to reduce the weight, especially on the wing. And how do you do that with solid rivets? And I just don't want to introduce soft rivets to this company or a builder's workspace, because how are they going to keep them straight? And it'd be, you know, just the thought of them mixing it up in the wrong location where you needed a high strength rivet with a, you know, and not noticing that the high strength has a little dot in the center. No. So what we've done since Oshkosh is I worked with our assembly manufacturer, Quick Build facility over in the Philippines, and they did a whole bunch of test samples with solid rivets, and it looks beautiful on thin material, regular 80 rivets. So we'll definitely be able to offer quick builds with the solid rivets from Vans on the 15. And I think that's the ticket. If you don't want to take the time or don't think that your riveting skills are up to it, but if they are, you will be able to, you know, take the parts out of the box, dimple them for the solid rivet, and go at it. But yeah, it looks like we'll be able to offer a quick build solid riveted option for the 15.
Wow. And will it still be an option for people to go with pulled rivets?
Yes. And after we started building the prototype, we really didn't get into the prototype till February.
The main structure of it, yeah, the bulk of the work.
Yeah, the bulk of it.
Yeah.
And, you know, we had to get this thing done by Oshkosh. And it's a brand new design. We'd never done a high wing before, so we wanted to leave enough time at the end that we weren't unsafe in the flight test program. So that can tell you how fast we built this airplane. And we realized just the benefit of the blind rivets and how much more rapidly we were able to produce that airplane with blind rivets. And plus, if you got one guy in one shop, you know, if that's what he wants to do, or her, him or her, if that's what they want to do, then more power to them.
Well, I can say, as someone building with a whole lot of blind rivets behind me, I am a fan of it. I will say there's advantages, as you mentioned, to both, but it's not, when I saw that at AirVenture, I was looking at that thinking like, wow, this thing would go together quick and easy.
Right.
Well, I think even some of our engineers that have been involved in the project have, you know, their initial opinion was,
yes,
pulled rivets bad, don't accept it. But then after being involved in building, and then after actually seeing the testing and being hands-on with the pulled rivets, they realized, you know what, there's something to this. And
yeah, we have Bernardo Malfitano. He's out of Boeing, and he's done fatigue tests for them. And you know, he had RVs. He's owned 2 RVs, and he jumped at the chance to come work for us. We're thankful to have him. And we have a fully, we could do certified fatigue work here. That's how professional our fatigue test setup and machine is at Vans. And of course, he's a professional at it. And we determined the fatigue life of an LP4-3 is great. You go to the CS4-4, and you'd have to have much closer spacing. They're not that great. But you know, compared to a solid rivet, yeah, probably a LP4-3 is comparable to soft rivets, at least for the first 20,000 hours, and then it starts to divert, and the soft doesn't look quite as good.
Right. Yeah, at that point.
Right.
So as through the fatigue life, the LP4-3 pulled rivet actually appears to hold up better over time, although both hold up for a long, long time.
Yeah.
In the test.
But we have rivet spacing designed into the airplane to go both ways. So, and then the way it's constructed, there's no place except for the top of the A pillars currently where you'd have to use. It's just so small as the front pillar gets narrow and near the top that you can't get your hands inside. We didn't want to compromise the design just to allow you to get a bucking bar in there. So.
Right.
Yeah.
No, that makes a lot of sense. So as we get closer to the top of the hour, what's going to be the next, I guess, data point or next information for people when they want to follow what's going on with the RV-15, if they're kind of sitting there chomping at the bit?
Right. Well, we're in flight test. We're abusing the airplane right now, abusing the landing gear. Yep. We've got the flap system to full deflection, so we're working through that, trying to get our landings shorter.
Yep. Yeah, we've made changes to the landing gear configuration and the pressures and just the suspension performance. And like you say, flown to a full 50 degrees of flaps.
Right.
which I hear was interesting.
Yeah.
So, and learning a lot. I
It
think,
wasn't an unsafe condition. We can say that.
oh yeah, no, not
But
interesting
but
bad, but you know,
we still have a lot to learn from it.
right. I think that there's not going to be a whole lot of big news for the next little while, and the reason is that, you know, as Ryan said, you know, we're doing this iterative testing program where we have certain things that we anticipate, and we're approaching things. And keep in mind, this is a clean sheet design, right? It's a brand new airplane, and it does behave in ways that are different in certain configurations and regimes than another RV would. And so, you know, the approach to this is to, you know, a iterative testing process, and it's flying most days right now, and making good progress. But we have a lot of, we will learn from what that experience is, and then we will refine and we'll make changes, and then that will go into the next set of iterative tests, and then eventually out the other end comes, you know, a final kit design. I think we've said that we expect, you know, kit availability for the first kit potentially, if we're guessing, and I would definitely say guessing, you know, in the 12 to 18 month time frame was what we're shooting for. But fundamentally, what we're really going to do is we're going to continue to develop and iterate until we get it right.
Makes sense.
I like what Ryan has said, and I've heard him say in the past, which is, you know, we'd rather do it right than do it right now. You know, I'm paraphrasing, of course, but, you know, I mean, I think that
it's good we have marketing people to rephrase your phraseology.
Yeah.
Poor engineers, we don't have a hope.
Grammar, please.
Yeah.
Excellent.
We're excited about it. You know, I'm confident that people are going to love the airplane. It's going to be a special airplane. It's going to be a lot of fun.
Wonderful. Well, Rian Johnson and Greg Hughes, President and Vice President of Vans Aircraft. Guys, thank you so much for taking time this evening to join us here on Social Flight Live and talk about this amazing and exciting new aircraft and all of the work that you're doing at Vans. I have an awful lot of respect for that, and my hat's off to both of you.
Well,
thank you much for the opportunity.
Yeah, we appreciate it. It's good talking to you.
Absolutely. I hope you'll come back and we'll get some updates on this and everything else happening at the factory in the future.
Glad to do it. I'm glad to do it.
Absolutely. Have a good night, guys.
Good night.
And to all of you, thank you so much for taking time out of your evening to join us here on Social Flight Live again for another wonderful evening with some of the most inspiring people from General Aviation. In next week's show, Tuesday, September 13th at 8 p.m., former Thunderbirds pilot Nicole Malachowski will be here on the show talking about pilot health and some of the challenges that she's overcome and is working through in her life. It's going to be a truly inspirational show, and I'd encourage you to put that on your calendar to be with us next Tuesday evening, September 13th at 8 p.m. for Nicole. She's truly a spectacular and wonderful individual. The following week on Tuesday, September 20th, Lightspeed Aviation founder Alan Schrader will be here talking about some new news out of Lightspeed, so be sure to check that out. Very cool stuff coming. And on Tuesday, September 27th at 8 p.m., as always, we're here with Don Durston from NASA's Ames Research Center talking about the X-59 supersonic aircraft and the work that NASA is doing on being able to break the sound barrier over land without the challenges that sonic booms present and have prohibited supersonic aircraft from being able to do in the past. It's going to be a very, very interesting evening with Don learning about what's going on there. Until next time, thank you again so much for joining us here on Social Flight Live, and I wish you all blue skies.